This honors geometry lesson, section 4.2, is on the ways to prove that quadrilaterals are parallelograms. So the objective for this lesson is to determine and utilize 5 ways to prove a quadrilateral is a parallelogram. If both pairs of opposite sides of a quadrilateral are parallel, then by definition, the quadrilateral is a parallelogram. The following theorems will give you additional ways to prove that a quadrilateral is a parallelogram. Theorem 4-4 states if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we want to try to prove that if we're given two pairs of opposite sides are congruent in a quadrilateral, that is enough information to prove that this quadrilateral is a parallelogram. So we're going to go ahead and try to prove this. The first thing I'm going to do is draw our diagonal QS. Then I'm going to label a few angles. I'm going to label this angle 1, angle 2, angle 3, and angle 4. So if we are given that TS is congruent to QR and that TQ is congruent to SR, we want to prove that quadrilateral QRST is a parallelogram. So based on what we know with the reflexive property, we can now state that QS is congruent to itself. Then what we notice is the two triangles created by that diagonal are now going to be congruent based on side, side, side. And what I'm going to do next is mark my congruency for my angle. So now I know that angle 1 is congruent to angle 2. And that angle 4 is congruent to angle 3. And if you notice, angle 1 and angle 2 and angle 3 and angle 4 are in the position of alternate interior angles. So remember, with the converse of alternate interior angles, if you can prove that they are congruent, then you can prove that the sides indeed are parallel. Because we know that angle 1 is congruent to angle 2, we can prove that TQ is congruent or parallel to SR, and we can also prove based on angle 3 congruent to angle 4 that QR is parallel to TS. So now, based on the fact that we are given that two pairs of opposite sides in a quadrilateral are congruent, we were able to prove that the opposite sides were also parallel, and by definition, this is also a parallelogram. The next way to prove that a quadrilateral is a parallelogram is with theorem 4-5. If one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So again, we have quadrilateral ABCD. I'm going to draw in diagonal CA, and I'm going to mark the given information. So we are given that AB is congruent to CD, and we're also given that AB is parallel to CD. So what I'm going to try to do now is I want to prove that opposite sides are parallel and making this quadrilateral into a parallelogram. So the first thing I'm going to notice is that AB is parallel to CD, which means that based on alternate interior angles, angle BAC is now congruent to angle CDA. Also, using our reflexive property, I can mark that segment AC is congruent to segment AC. So based on my markings, I can now prove these two triangles congruent based on side angle side. And then based on side angle side, I can now mark that these two angles must be congruent to themselves using CPCTC. And remember those angles marked, so if I mark this angle 1 and angle 2, angle 3 and angle 4, since angle 1 and angle 2 are congruent, we know that side AB is parallel to CD, but we were also given that information. And based on CPCTC, I now know that angle 3 is congruent to angle 4, which also makes BC parallel to AD. So now we were able to prove that opposite sides are parallel. Therefore, this is a parallelogram. The next two ways to prove that a quadrilateral is a parallelogram are theorems 4-6 and 4-7. 4-6 states if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. The next theorem, 4-7, states if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So remember, if diagonals bisect each other, at the midpoint, the two segments are congruent. We are actually going to look at these proofs for theorem 4-6 and 4-7 in the next class. Before we move on to the last theorem for this lesson, let's review the 5 ways to prove that a quadrilateral is a parallelogram. In the last lesson, we learned that a quadrilateral is a parallelogram if both pairs of opposite sides are parallel. In today's lesson, we learned 4 additional ways. So we can show that both pairs of opposite sides are congruent. We can show that one pair of opposite sides are both parallel and congruent. We can show that both pairs of opposite angles are congruent. And lastly, we can show that the diagonals of the quadrilateral bisect each other. The last theorem we're going to discuss today is theorem 4-8, which states if 3 parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So let's say that we are given these 3 parallel lines, which are the blue lines, and we're given transversal AC. If AC has a midpoint of B, and the markings indicate that AB is congruent to CB, then on the second transversal, XY, it means that XY is not going to be congruent to YZ. It doesn't necessarily mean that AB is congruent to XY, but what it does mean are the segments that are congruent in one transversal are congruent, then in the other transversal, it also makes those segments congruent as well. This can also be applied in a corollary relating to triangles. So here we have triangle ABC. This corollary states a line that contains the midpoint of one side of the triangle and is parallel to another side of the triangle bisects the third side. So let's say that we have triangle ABC and we look at side BC. We also have line MN, which we know is parallel to side BC. M is the midpoint of side AB. So if we draw line AD and also make that parallel with MN and BC, based on theorem 4-8, if we know that AM and MB are congruent, then since these 3 lines are parallel, we also know that AN is going to be congruent to NC. And please remember that even though those segments are congruent to each other at the midpoint, it does not necessarily mean that segment AM is congruent to segment AN. This is the end of today's lesson. If you have any questions, watch the video for a second time. After watching the video for a second time, if you still have questions, write down any clarification questions you may have and bring them to the next class.